The birth of gravity. Isaac Newton's journey from inspiration to revolution. In the mid-1660s, the world was being ravaged by the Great Plague of London, forcing a young Isaac Newton to leave Cambridge and return to his family's home in the countryside. During this quiet period, away from the bustling academic life, Newton's mind began to race with ideas. It was here, as the legend goes, that he saw an apple fall from a tree, sparking his curiosity. Why did objects fall straight down to earth? This question would lead him to develop one of the most revolutionary ideas in science, the theory of gravity. The spark of an idea and the seeds of a theory. Newton's fascination with the forces governing motion wasn't an overnight discovery. It began around 1665 to 66, during what's known as his annus mirabilis, or miracle year, when he delved deeply into calculus, optics, and motion. Though he was only in his early 20s, he was developing ideas that would change science forever. Still, gravity was only a seed of an idea. It would take years to blossom into a full theory. A rivalry ignites, Newton and Hooke. Fast forward to 1679. By now, Newton was back at Cambridge and intensely focused on his work. He began corresponding with Robert Hooke, an influential scientist and the secretary of the Royal Society, who invited Newton to share his ideas on the motion of planets. Hooke, a sharp thinker himself, had proposed that planetary motion followed an inverse square law, where gravitational pull decreases as distance increases. But Hooke lacked the mathematical proof to support this. Newton took the bait. This exchange with Hooke stirred something in Newton, who decided to revisit his early ideas. Over the next several years, Newton transformed this notion of an inverse square law into a mathematically rigorous theory. He calculated that a force acting inversely with the square of the distance could, indeed, result in the elliptical orbits of planets, as described by Kepler's laws. Newton's work now had a clear direction. The great work begins, De Motu Corporum Ingerum. By 1684, Newton had produced a short manuscript called De Motu Corporum Ingerum, or On the Motion of Revolving Bodies. In it, he proved that planets move in elliptical orbits due to a centripetal force, an inward force pulling them toward the Sun. Newton shared this work with Edmond Halley, an influential astronomer who was so impressed that he encouraged Newton to expand it. This short paper became the kernel of Newton's grand opus, the Philosophiae Naturalis Principia Mathematica, or simply the Principia. The birth of the Principia, a monument of science. In 1687, with Halley's financial support, Newton published the Principia. This groundbreaking book outlined 3 fundamental laws of motion that describe how objects move in relation to forces acting upon them. These laws are so powerful and universal that they still underpin classical mechanics today. They were revolutionary, providing scientists with a reliable framework for understanding everything from the orbit of planets to the motion of cannonballs. It was in the Principia that Newton also introduced his famous law of universal gravitation. He used the Latin word gravitas, meaning weight, to describe this force that attracts objects to one another. Newton demonstrated that this force operates not only here on Earth, but across the vast distances of space, keeping planets in orbit around the Sun. For the first time, humanity had a unified explanation for both earthly and cosmic phenomena. The strain of genius. Newton's struggles with gravity, but the work was not without its toll. Newton pushed himself to his mental and physical limits, especially when studying the gravitational effects on the moon's motion. He became so consumed with solving these complex problems that he lost sleep, his appetite diminished, and he suffered from severe headaches. As he confided to a friend, "My head never ached, but when I was studying the subject." Even when he completed his theories, he avoided delving into the specific cause of gravity itself. Newton's ideas seemed almost magical to some, as if he had invoked an invisible occult force that could reach across empty space. His critics, including the philosopher and mathematician Gottfried Leibniz, questioned how gravity could work over such vast distances without any physical contact between objects. Newton, undeterred, replied in the second edition of the Principia that it was enough to describe how gravity worked. He was not obliged to explain why it worked. Hypothesis non fingo, he famously wrote, meaning I feign no hypothesis. A final breakthrough, the heliocentric solar system. Newton's insights went beyond just explaining gravity. He was among the first to understand that the center of the solar system wasn't exactly the center of the sun. Instead, he showed that all bodies in the solar system orbit around a common center of gravity. This idea, though subtle, was revolutionary. It made the solar system more dynamic, revealing that even the sun is pulled slightly by the planets orbiting around it. Newton had taken the heliocentric model and refined it in a way that was profoundly modern. His legacy, from obscurity to global fame. With the publication of the Principia, Newton became an international sensation. Scientists across Europe marveled at his insights, and he attracted a circle of followers, including the Swiss mathematician Nicolas Fècheux de Dullier. Newton's ideas paved the way for centuries of discovery and even provided the groundwork for the technological advances of the Industrial Revolution. His three laws of motion and the concept of universal gravitation remain at the core of modern engineering and physics. In the following years, Newton continued to explore mathematical topics, including the classification of cubic curves. By 1710, he had identified 72 of the 78 types of cubic curves, laying foundational work for algebraic geometry. Newton's journey from a young, curious scholar to a revolutionary scientist left a legacy that shaped modern science and our understanding of the universe. Closing thoughts. Isaac Newton's discovery of gravity wasn't a momentary epiphany. It was the result of years of relentless pursuit, collaboration, and even rivalry. His Principia didn't just explain gravity. It provided a new lens through which humanity could view the cosmos. His discoveries remind us that even the most extraordinary achievements can emerge from humble beginnings, and that the power of curiosity can truly transform our understanding of the universe.